Hi everyone, are you able to hear me and see the screen clearly? Great, great. Hi Jim, hi Prasad, hi Amog, hi Veena, hi Anaga, hi Vinod, hi Tarun. All right, all right. It'll be great that if I could give you a name instead of a number. There is one person with a name 18849. I think you can change your name, please. That'll be great so that I can address you. Okay. All right. I think it's Ganesh. All right. All right. A question from Veena is, can you please record this session and send us the link? Of course. That's the usual format that the entire session is recorded, so you don't have to worry about it. All right. A question from Amog that I'm a beginner in programming, but have some interest in learning about AI, machine learning, IoT, etc. So be a part of this session. If you are beginner in the programming, so I think it'll be better to actually continue this session. This session is for all. Okay. All right. This session is for all. It's not really for somebody who is looking for in-depth knowledge. Okay. So this session is a general session. So you must stay with this session at least. Okay. So please be part of this session because this session kind of touches upon the ecosystem, and that will help you in understanding what's going around. Okay. All right. Anil, could you ask these questions using Q&A? I would love to answer it after selecting your question so that people know that I'm answering certain question. All right, Amog, I hope I've been able to answer your question. All right, there's a question from Sandesh. Hi, I'm Sandesh. I could not see the screen. Can you share the screen, please? It's being actually shared with everyone. I hope everybody is able to see the screen. Please respond by raising the hand. All right, so I see that everybody is able to see the screen based on the hands. Wonderful, wonderful. Okay, great, great. All right, so a question from Anil is, how strong needs to be in Java for big data? Not much. Okay, this course which we are running, this one, what we have done is it generally do not require any kind of programming language experience, but it does not explicitly require Java experience. But if you have some prior programming experience, it'll be great in this course because we assume that you have done some programming you have done some programming earlier. Okay. First session is open for all. First session is a generalist session to give you an overview of big data and Hadoop and Spark ecosystem. So, uh, so therefore, for first session, you don't require any kind of knowledge on programming. But for rest of it, for rest of it, for rest of it, you would require a bit of programming language. All right. In case of Spark part of the course, in case of Spark part of the course, we teach you Scala along with Spark so that you can do Spark programming properly. Okay. I hope that I have answered your question, Anil. Great. All right, great set of questions. Keep the questions coming. We have still some time before the session starts. We have around 6 more minutes to start the session. Any other question you have? Please feel free to ask. All right. I love to answer the questions, and that's why we run these sessions so that your questions can be answered. A question from Andy. Is there going to be some sort of certification given at the end of course? Yes. If you, after every course, we give 2 projects. If you finish those projects, you will be able to get our certificate. Also, this certificate, this course is very much tuned to the existing certifications by Cloudera, Hortonworks, and therefore, you will be ready for the certification by them as well. Although we provide our own certificate at the end of project. A question from Sanjaya. How many projects you provide to work on? As part of this course, there are smaller problems and bigger problems. Bigger problems are in the project format, and smaller problems are in the form of small assignments. Okay, there are many small problems that you need to solve. Some are in the form of quizzes, some are in the form of subjective questions and hands-on assessments. And in and with respect to the project, the large problems, for that we provide around 3 to 4 problems in general. One is related to the recommendations on movies. Other is related to the sentiment analysis using Hive and using real time. And there's another problem about churning the logs using Spark. So those are the 3 sample projects that we provide as part of it. If you have done really good job and as in you have finished the project in a above expectation, then what we do is we generally put you in the real-time project. All right. A question from Sri Yukta. Sir, any prerequisites to learn Spark? So if you are learning Spark, it'll be great if you have some exposure to one programming language, either Python, Scala, or some other. Second, you should be comfortable with basics of SQL. then you will get the hang of it. And if you are asking about attending the Spark course here with us, with CloudX Lab, then if you're attending the Spark course with us, then you just need the basics of any programming language and basics of SQL, because Scala we are covering in the course. Basics of Scala required for the course, we will teach you in the course. And so you should be covered there. All right. A question from Vinoda. I'm certified in Python with from O'Reilly. Great. And how helpful for me to would be to get into big data? All right. Very good question. So I think for you, the next step would be to get an exposure to Hadoop and Spark Stack, because in in days forward, most of the analytics, or most of the high speed, high performance computing will be on these stacks. So it'll be very useful for you to move ahead into the big data ecosystem. All right. A question from Tarun. Should I learn statistics, machine learning, and AI to be in Hadoop development feed? No. Statistics and machine learning and AI are part of machine learning and data scientist kind of job. Here we are talking about Hadoop engineering. For this course, you require is some basic amount of programming experience, basic amount of SQL, and and a little exposure to the operating system such as Unix. All right, that's all. A question from Sanjaya. Any project on telecommunication side or networking side, because I'm from networking background? We do not have as such, but we can figure something out. If you have something in mind, please feel free to communicate. All right, great set of questions. A question from Anup. I'm a senior Java developer. Will this course be helpful? Yes. This course will be helpful for you, because after Java, you have done most of the, you will have to, let's say you have in your organization a big data platform and you have to build applications around it. In those cases, this course will be useful to you. All right. Question from Aritra. How much competency is required in Linux to learn Hadoop? Basics of Linux. Okay. We also provide a tutorial which you can attend to using our CloudX Lab homepage. Okay. If you go here, I'll just show you quickly so that. All right. So if you go to cloudxlab.com, you can simply attend the Linux tutorial. If you go down a bit, the first one is the Linux tutorial. You just attend to it, and that will be good enough. Okay, it's a general Linux tutorial, and it should help you understanding the Linux ecosystem. A question from Rahul. I have database background with bookish knowledge of Java. Will this session help to learn easily? Yes, definitely. Okay, our courses are very hands-on. So, and the entire ecosystem that we have built is around making people hands-on. And that's why we have built automated hands-on assessment. We have built CloudX Lab, the lab, and we have built the entire mechanism. Even the course has been structured such that we prefer the practical before the theory. You will see from session second onwards that we are very, very practice oriented when it comes to the course. A question from Yadagiri. I'm a senior BI developer. Is this helpful for me? Yes. Okay, because as we go forward, the most of the analytics is going to turn into the on bigger data, and therefore it'll be useful to you. All right. So we'll start the session in like 5 minutes, and we'll just take one more question from Anhul. So we have Anhul. He says that I'm a mechanical engineer, worked as a trainee in past. Please tell me how can I start working in a software industry? Okay, it's a very good question. Probably there are others as well who have faced this challenge, and my friends also have similar challenges in past. Therefore, it's a very important question to answer. So basically, when you are from a different background, and as a matter of fact, I'm a chemical engineer, but I have worked for 15 years in software industry, built various platforms. So therefore, the industry kind of accepts, from all kinds of background, from all kind of branches. All right. So the so this you should not be worrying about the engineering background. Okay. So the simpler thing would be to get yourself acquainted with any programming language. Okay. Such as Python or maybe Scala or some one programming language you get yourself ready with. Okay. Then you try to build basics of algorithms using, say, HackerRank or using HackerEarth, basics of programs. All right. That should give you a good amount of confidence. And afterwards, while you are doing so, while you're doing so, while you are doing so, once you're done with basics of programming and so on, pick up a vertical which is kind of recently trending. Okay. The good part about newly trending, new topics is that you do not get too much of competition. Okay. So for example, big data or maybe machine learning or maybe some other domain which is in the demand, and which means that there won't be too much of competition for you, and that will help you to to get back to the software industry. All right. You can start working with SQL somewhere, like you can start with, either if you are not getting a break, you can start with QA, or you can start with the analytics positions. So that's how you can get started with the software industry. All right. You can write to me, or you can post your question in the discuss, and I would love to answer this in the details. All right. I hope I was of help to you, Anhul. Okay, so Santosh, you're having 3 years of experience. How is it helpful for Santosh? Okay, so if you, even if you are in the beginning of your career and you have basics of knowledge of programming, it'll be useful to get into such a course because it gives you the entire experience of working on the technology stack. All right, very great set of questions. And all right, so I'll continue with my discussion, and then we'll take, after like 15 minutes, I'll take the second set of questions. Okay. Bhuvan, you can also ask question using Q&A window. That'll be easier for me to answer. All right. Okay, so is my voice clear to everyone? Please raise your hand to say that it's working. All right. So I can see 31 hands. That means everybody is able to hear me very clearly. Okay, great, great. All right, great, wonderful, wonderful to have all of you in the session. And I would love to answer your questions as we go ahead. So to get started, we will take your questions after 15 minutes again. but you keep on asking questions. It's just that I'll not be answering your questions. So as and when the question comes to you, your mind, you just ask using Q&A window. All right. So I would love to answer your question. All right. So welcome to the Big Data with Hadoop and Spark session. This is the first session. It's a introduction to introductory session. It's a session one. And regarding this session, it's a 3 hours duration from 8 to 11. All right, nine minutes are already over. So in the first half, we will understand the basics of big data. Then we'll take a 10 minutes break. In the second half, we will talk about Hadoop and Spark architectures. And this session is being recorded, and recording and presentations will be shared with all of you. If you have registered with your email ID, all of you will get a copy of this presentation. To ask questions, please use Q&A window, not the chat window. All right. Let me just put it a Q&A window. So please ask questions using the Q&A window. Except for me, everybody is muted. And while answering the question, I'll read out the question before answering it so that the voice get recorded. To get better answers, please keep your messages short and avoid chat language. All right. This is the session one of our 14 sessions. This session is an open session for all, and it's an introductory session, and it generally suffices as an introduction to the big data technology stack. All right. Good. About the course instructor, I'm Sandeep Giri. I graduated from IIT Roorkee a long back and worked on large-scale computing at Amazon in Moby at DE Shaw. At DE Shaw, we were handling big data even before the term was coined. What do I mean by that is the kind of data we were churning was really humongous, and we had a 10,000 node cluster in 2002. Okay. And then I worked with InMobi, where I processed around 200 terabyte data. When I say churned, churned is equivalent of processing. At InMobi, we built the recommendations for our end users after processing around 200 terabyte data. And then I joined Amazon, where we built high performance computing platform. Also, we took care of the Amazon detail page for mobile devices. I'm software engineer at heart, and I love explaining technologies. I have this. I enjoy explaining the technology to the friends, family, and or whosoever I get hold of. All right, and that's kind of I enjoy completely. Okay, so I founded CloudX Lab. Before this, I founded another company in Hyderabad, and so basically at CloudX Lab, we're building the learning mechanisms for everyone. All right. The objective of this entire course of 14 sessions, this session one of those 14 sessions, is to learn to process big data with Hadoop and Spark. All right. So, and we will learn all the related technologies which come on the way as a prerequisite for others. All right. The course structure. So we have 4 things as part of this course. One, I will be answering your questions and teaching you the entire course using a similar mechanism like what we have. Second, we will have the sessions recorded so that in case you miss something, we will have everything. Third, we have a self-paced course on CloudX Lab, meaning we have recorded these sessions and kept it ready for you so that you do not have to, you can take it at any point of time. All right, that's self-paced course. And along with all of this, we have assessments and quizzes and projects. All right, the course structure is, for the self-paced course, the online course is, you have got videos which are studio recorded videos, not from the live sessions. They are separately recorded. Second, we have quizzes and assessments. Then there is something called a hands-on that's unique about our course, in which we give you a challenge and you have to solve it in the lab, and it automatically validates you. The fourth one is the projects. We provide you the projects so that you can learn end to end of the end to end problem solving. And we also provide you case studies as we go. All right, that's the course structure. All of these are built around real life use cases. Okay, so we focus a lot on the learning by doing. For that, we have built hands-on assessment along with the usual video and live instructor led. Okay, so what is hands-on assessment? You are given a problem statement. You will have to log in and do the hands-on, and afterwards, automatically your work will be assessed. All right. So this is an example of evaluation whereby you're given a problem statement and you are asked that to open a console. And once you're done, you click here. And once you have clicked here, it basically will check whether you have actually launched a console or not. Okay, this is just one example of assessment, the initial one. To take a look at the courses, you can click on my courses, or you can click on your login here and you will start seeing the courses. Okay, so my courses would look like this. All right, and under my courses you will see all the topics. All right, so the topics contain the learning items. Learning item could look like a video, could be a text, could be a quiz, or could be a hands-on assignment, or it could be a combination of all. All right. For videos, if it's a video, you have to mark as complete when you're done. So here we are talking about self-paced learning, while the normal live classes are like this one. All right. A question from Anil. What are the full topics that are covered as part of the course? Let me just answer this before diving into anything else. This is something important. So let me just go to CloudX Lab, and if you click on, let's say, tracks, or yeah, tracks, and click on this one, view detail, and preview course, you can see all of the topics that are covered as part of this course. Let's start with course overview, big data introduction, that is today. Then we'll go to lab overview. Then we will give a basics of Linux, although the same is available online. Java essentially is something you have to do it by yourself. Then Zookeeper will be covering HDFS, Yarn, and so on. All right. So this is the full list of topics. Okay, it's so it's a superset of most of the certifications. So it's probably the biggest and most complete course available online. Okay, that's why it goes to 14 plus sessions. All right, so that was about the course and about about the instructor. And again, I'm Sandeep Giri, and feel free to ask questions as we go ahead. All right, so let's start with very basics of big data. And yeah, So we start with the very simple introduction of big data. But before that, let's clear a couple of terms. Couple of terms like there are the data is classified as structured, semi-structured, and unstructured. Structured means we know what are the fields. We know the field's data type, right? Like in Excel sheet, we know what are the columns, and we also sometimes know the data type of entire column. Semi-structured data, you know about the fields, but you do not know about the field's data type, right? So examples of structured data are, the examples of structured data are like a database. In database, we know clearly that what are the fields, okay? What are the fields and their data type, right? If you have worked with SQL, you would know that when we create a table, we have to define the columns and we have to also specify their data types, okay? Therefore, a database table is structured. All right. Second is semi-structured. In semi-structured, we know about the fields, but we do not know the field's data type. An example could be a CSV or XML without the data type. The third one is unstructured. In case of unstructured data, we neither know the fields nor we know the field's data type. Also, unstructured data may not confine to the tabular structure, while structured data would be some form of tabular structure. So this is the simplest definition of the structured, unstructured, and semi-structured data. Converting an unstructured data. Examples of unstructured data is logs, Apache server logs, as well as other plain text file like text of some ebook or or voice recordings. That's unstructured data. Converting this structured data to structured, converting this unstructured data to structured is called ETL. ETL stands for extract, transform, and load. All right? Extract, transform, and load. All right. So the next thing is distributed systems. Okay. Before going ahead, like to answer Anoop's question. JSON is unstructured or semi-structured. JSON JavaScript object notation is mostly structured data. Okay. JSON is structured data because in case of JSON, every object has clear definition of fields, and also we know the data type of the field, right? When you're creating a variable in JavaScript, JavaScript object notation, you always have the data type associated with it. Just that the data type is automatically inferred in case of JSON, but it has a data type. Good, great set of questions. All right, the other very common things that you will encounter is distributed computing. What does it mean by distributed computing or distributed systems? Distributed systems, distributed systems are basically groups of networked computers that interact with each other to achieve a common goal. To achieve a common goal. Okay, so this is basically all right. So coming to the point, when you connect multiple computers together and you let them solve a problem, let them solve a problem, such that all of these computers are interacting with each other. That's called distributed systems. Okay. All right. How many bytes in 1 petabyte data? A quick question to all. All right. Yes. Thank you, Nilesh. This just to check if you are listening and attending to them. Great. Great. So you are right. The the number of bytes in 1 petabyte is around 10 to the power 15. Okay. Just to check our knowledge. Great. A question point from K. Kumar. The JSON is semi-structured in my opinion. And yes, so JSON is sometimes considered as semi-structured and sometimes it's considered as structured based on how we define object. But if you load the same JSON as a table, you can do that instantaneously. So as per the JSON definition of structured, it kind of okay, just that not all objects could be instantaneously converted immediately. Say for example, JSON array may not be a good example of structured data, while JSON object could be. All right. So that's a good point, K. Kumar. All right. A question from Nabil. Is distributed computing same as parallel computing? As per the terminology, the distributed computing is probably a part of parallel computing. Okay. Parallel computing means getting things done parallelly, either using multiple processors, multiple cores, or multiple machines. Howsoever, getting things done in parallel manner is called parallel computing. There are something called GPU, general processing unit. Okay, so that's basically a GPU processing. That's also part of parallel computing. And distributed computing is just one instance of parallel computing in which the work is getting done parallelly using many computers. Very good question, Nabil. All right, wonderful. Now, moving ahead, how much data Facebook stores in one day? Any guesses? Around 600 terabyte data. As per their website, as per their disclosure, they're kind of storing 600 terabyte in one day. I'm not sure about the current number. This number must have gone up. All right. So now coming back to the main definition of big data. All right. Actually, there was, all right. All right. So let's come back to the definition of big data. So what do you think is big data? You can answer to this using chat. No, your own understanding, not three V's, please. What's your own understanding? Why are we asking this question? Because as we go forth, we will everything we talk about will be focused around big data. It'll be around big data. Therefore, we want to clear our own definition of big data. Wonderful set of questions. Wonderful set of questions. As a thumb rule, I will take M. Vaidyanathan's answer as it's a interesting answer. M. Vaidyanathan's answer is that data which is too huge or complex that cannot be handled by databases. It's a very predictable way of looking at it. Great, great set of questions, great set of answers. All right, wonderful, wonderful set of answers. I think most of you have answered it. Let me reiterate your answers. Let me reiterate your answers. It's simply data of big size, data of very big size. All right, it could be any. There is no exact number. There's no exact number. The data of very big size that you cannot process using your usual tools, such as usual file systems, usual databases. All right, that kind of database, that kind of data. And for handling such a data, you generally end up using distributed architecture. Okay, so you end up using many computers in order to handle data. Now, definition of handling depends upon what problem are you trying to solve, right? When I say handle data, handling is based on your requirements. So same data, if your handling needs, your processing needs are lower, same data could be normal data, but if your requirements or your need, the problem that you're trying to solve is complex, the same data could be impossible to handle using your usual systems. All right. And therefore, you would require distributed architecture. All right. So you all have kind of answered this question, but I would focus more around distributed architecture needed. Every tool in this course, the course we're talking about, the session one of this course, this is session one of the course. So every tool that we'll discuss during the course will be around distributed architecture, almost all of the components that we talk about, starting with zookeeper onwards, they're all around distributed architecture, or they are prerequisites. For example, Linux and Java and those kind, or Scala, those are kind of prerequisites for these tools. So 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 anything that we talk about in this course, we will be around distributed architecture. All right, I'm not going beyond three V's. So this is the standard definition of big data, and it's actually the characteristics of data. These are characteristics of data, and it's in terms of three V's: volume, velocity, variety. Volume means how to store data, data at rest. Velocity means handling the speed. Are you able to hear me? Yeah? Good, good. Thank you by showing that raising hands. All right. Suddenly there was another user with the same name. Therefore, it got. All right, great. Now going back to the definition of big data, so it's defined by three characteristics, or you can say that data has three characteristics: volume, velocity, and variety. Volume means the data could be huge. It's so huge that it's difficult to store using usual tools. So problems related to storage of huge data reliably. For example, storage of logs of a website, storage of data being done by email server like Gmail, like Facebook, they're storing 600 terabyte per day. So how to store humongous data? If that is the problem that you're facing, then your problem is volume. Okay. If you're getting too many requests or your data is, you need to handle data at a very fast pace. And if that is your problem, and for that you are not able to do it using usual tools, then velocity is the characteristic of the data that is in the play. Okay. For example, number of requests being received by Facebook, YouTube, or streaming videos using YouTube, or or number of page views being handled by Google Analytics. Why Google Analytics? Because Google Analytics code is embedded in every website, and any website that is visited around the world, most of them would hit the Google Analytics. Therefore, these are number of requests handled by Google Analytics. So that's velocity, number of requests coming in per second, and to be able to answer those requests in time is handling the velocity. Third is variety. Data could be in many form. Now I would like to kind of detail the variety part. Okay. So data could be in many forms. That means your problem could be to to solve the okay, so the variety means data could be in many forms, or your problem could be to your problem could be decently complex. For example, machine learning problem, right? Or finding location from one point to another. So problem involving complex structures such as maps, social graphs, recommendations is called variety. There could be a variety of problems, all right? Or complexity could vary based on different variety of data or problem. So because of these three characteristics, either one of the characteristics or more, your your problem is rendered impossible using the existing tools. Okay, let me reiterate. So because of either of the three characteristics, you may not be able to use your existing tools to solve your problem. Therefore, you will say that my problem is big data problem. Okay. I- So because of any of these three characteristics, I'm ignoring the fourth V's or fifth V's and so on. All right. Now the variety, I'll give you more examples of variety. For example, let's say you have Google Map. Okay. You want to go from one point to another. Even though Google Map might not require too much of storage, it might be, say, 50 gigabyte of data, right? But finding path from one point to another is a complex process. You need to go through every possible permutation of paths. And therefore, finding path, finding most optimum path is the important problem to solve and is a hard problem to solve. Okay, so and therefore the processing need required for a map, for finding a way from a point to another point at a map is is a variety problem. okay, is a variety characteristic of data. All right. So again, problems involving complex data structures such as maps, social graphs, or recommendations are part of variety. Most of the machine learning or graph related problems are part of variety. All right. A quick question to just check if we all understand the this one. If we all understand the behavior of our computer's hard disk, the data on a data inside a computer is stored on a hard disk, and and there is a time required to read from the hard disk. All right. So my question is, what do you think would be the time taken to read 1 terabyte data from your computer's hard disk? We all have used hard disk, right? We have computers which has a hard disk. So HDD means hard disk drive. It's a magnetic drive. It has a header on top of it, and it rotates when we request for data. Okay. So it doesn't really depend on CPU as opposed to our understanding. Okay. Yes, it does depend on the speed and the type of the disk. So here we are talking about hard disk. So you can assume the fastest hard disk possible, or you can assume the average hard disk which we have in the market. It does not depend on the RAM because we are not going to store this data in the RAM. We can just keep on ignoring it. We are just talking about reading the data, not into the RAM, just reading and discarding. Okay, we're talking about one single hard disk. Thank you, Frank. It's a good point. And all right. No, Anil, you have not missed anything. Yes, you can assume an average speed. All right, so it takes around 6 hours, not seconds, not minutes. It takes around 6 hours, no matter what kind of RAM you have in computers. Okay, no matter what you kind of RAM you have in computers, or you what kind of CPU you have, you cannot bring it down unless you buy a really fast hard drive, or you move to say a solid state drive. So average time taken from a hard drive to read 1 terabyte data is around 6 hours. All right. Although, if you are trying to copy, say, 1 terabyte movies from one hard drive to another hard drive, it might take more than 12 or more than 24 hours, in my opinion. Okay, because writing speed is far more slower than the reading speed. All right. So this is an important point to keep in mind. Now, you would understand when I say volume, and we are talking about 600 terabyte a day here. You see, 600 terabyte a day. Okay, and and therefore therefore storing 600 terabyte is actually 3600 hours if it's a single drive. Therefore a distributed computing is required, meaning you require multiple hard disks and multiple computers to manage those hard disks if you are trying to store terabytes of data every day. All right. Now, second question to all of you, please pay attention. So second question is, if you have to count just vowels, let's say you have this humongous text of 1 petabyte size, and you have to just count vowels in that 1 petabyte data every day. Do you think do you think that you would need distributed system? All right, let me repeat. Let's say you have this humongous text and you just want to count how many vowels are there. Okay, how many vowels are there? And in the 1 petabyte data, do you think you need many computers to solve this problem, or you can get it done using one computer? So no matter how you keep this data, if we are just counting vowels, you will have to go through the text from left to right. Okay, even if you have created the indexes, even if you have done all kinds of mechanism of optimization, you will have to go through the text from left to right or top to bottom, and therefore you will need to read the hard disk, right? You need to read these disks in order to process data every day. Here we are not counting the words, here we are counting the characters. Good point, Andy. So great. So yes, most of the existing systems cannot get it done. All right. So you would require distributed systems. You would require distributed systems in order to just count vowels. Counting vowels is not a complex task. It does not require velocity or variety. It's just counting the vowels in the text, right? And there, even this kind of challenge is this would require distributed computing. All right. Therefore, this task can be said comfortably that it's a big data challenge. It's a big data problem. Okay. So this is a general graph showing how the digital data has been expanding exponentially. Okay. In this graph, what you see is the big data. The big data started happening at around 2002, the year probably I passed out from college, and and so on. So you can see clearly the digital storage has been expanding exponentially. All right, why did that happen? The answer is twofold. One is devices and other is connectivity. On the hardware level, we had devices, the mobile phone devices, and then connectivity. So if you think of your phone right now, this phone is mostly, if you are having okay, if you have the, just give me a second. I have some urgent call. Just give me a second. All right, so I'm back. Sorry for the interruption. Okay, so what I was talking about is why are we talking about big data? why did this expansion of data happened exponentially? The answer is twofold: the devices and connectivity. While on one hand, the devices became cheaper, faster, and smaller, connectivity also became faster and cheaper. And as a result of both, the lot of applications are able to provide some useful um, useful utility to people's life. So if you look at the device that we have in our pockets, it's actually more powerful than the supercomputers of 2002. Okay, so the devices have been growing, doubling in the capability every year. Similarly, the connectivity also has been improving. We have Wi-Fi, 4G, NFC, and GPS kind of connectivity as of today. All right. And around these hardware as well as connectivity, uh, we have many applications as of today, such as Facebook, YouTube, Twitter, Google, Flickr, and Android, and all kinds of softwares using which people can achieve something useful in their lives. Okay. So, so while on one hand, you can think of device as something that produces the data and connectivity as something that multiplies data. And that's the reason why data has been increasing every every second. For example, right now we have 100 plus attendees in this session. And this session after 3 hours will be basically transferring around 3 GB of data from my side to the servers of this tool. And from servers of the tool, all the 100 attendees will be getting the stream, which means 300 gigabyte of data would have been transferred by the end of it. So while these devices on my side are producing data, I mean, of course, I'm producing data, and the connectivity is multiplying it. All right. This is how to look at the device and the connectivity. All right. When we look at a computer, we can think of it as made up of four big components. One is CPU. In case of CPU, the CPU does the processing part, meaning it takes the instruction and executes it. Okay. If there are more instructions to be done, it'll take more time. And therefore, the number of instructions it can process per second is actually the thing that matters to us. Okay, so for complex processing, is the CPU that is required mostly, and but CPU is never a bottleneck in general processing. Second is the RAM. CPU generally reads the information from RAM because reading from RAM is extremely fast. Therefore, RAM, registers, or GPU memory, I'm calling all of that as the memory. Okay, so CPU reads the data from the RAM, and hence the speed at which CPU can read from RAM or write to RAM, as well as the size, how much RAM you have, is is an important characteristic when we are thinking about computing. The third one is hard disk. It could be it is basically a permanent drive, permanent storage, while RAM is something which disappears after the system is rebooted. Hard disk or solid state drive keeps the data unless it's deleted. Okay. In case of storage, the disk size and speed matter a lot. In case of hard disk drive, the disk size is big, but speed is slow, while in case of solid state drive, disk size is small and speed is big. All right. The fourth component, which we keep on ignoring mostly, is the network part. Okay. The network part is basically the The fourth component that we keep on ignoring is the network part. All right. So network does play a role when it comes to computing because almost everything as of today downloads data, uploads data, and from the internet. Therefore, network is a very important characteristic of a computer. All right. So when it comes to big data processing, at least one of these components will become a bottleneck. Okay. And as a computer engineers, as a programmer, what we keep on doing is shuffling the data between these four places. If let's say we are not able to fit data into the RAM, we will push it to the hard disk. Okay. If the hard disk is full and hard disk is smaller, we will push it to the network. Okay. And this at certain point, when it comes to big data, at least one of these devices will become the bottleneck and the overall computation will not be acceptable solution. Okay. And at that point of time, we will have to move to a big data solution. Now, quick question to all. You can answer using chat. And which components impact the speed of computing? A, B, C, D, E, F, G. Sorry, it got kind of disappeared. Yes, the answer is all of the above. Okay, so which of the components impact the speed of computing? It's not CPU alone. We always think of processor like because of the marketing by Intel and other people that CPU is the most important computing component. But no, you will be amazed to know that the first component that becomes the bottleneck is the memory in case of a web application. Okay, so the answer is all of these components could impact the speed of computing. Okay, all right. Now we talked about the data has been expanding and our existing tools are limited because of these various components and so on. Right? That's what we have discussed so far. So what are the applications of having huge data with you? How having bigger data is more beneficial to a smaller set of data. Imagine that we don't keep entire data, we just delete the older data. What are the things which we are losing out on? Let's take few examples. Okay, let's take few examples. The first example is e-commerce, and recommendation engine or recommendations are probably the most important part of an e-commerce industry because half of the traffic is driven by how great recommendation you give to the user. Recommendation could be as simple as customers who bought this item also bought that. Okay, and the recommendation could be like wear this with these items, right? Or recommendations could be very personalized, like the movies we think you will love are the following based on your past movie watching experience. Okay, so basically, recommendation is one such big use case which is being used by almost every e-commerce company. All right, and how do we do it generally? We prepare the user and movie and ratings. This is just very rudimentary and simple example to all of you. Okay, so you got user ID, movie ID, and ratings. in three columns. Then we feed it to, say, MLlib or Mahat, and then it provides us the recommendations. Internally, it is basically finding who are the similar users and suggesting them the suggesting them the the movies of each other. For example, Kumar and Giri are very similar to each other. Therefore, let's suggest some movies from each other. That's how some of the basic recommendations work. Okay, so if you see the okay, so basically the movie recommendations are one example of recommendations, and this is how it can be done easily. A component from Hadoop called Mahat or MLlib from Spark that's generally used for movie recommendations or any kind of recommendations. All right, great. Now moving on. Next is e-commerce. In e-commerce, this next example is A/B testing. What is A/B testing? A/B testing is instead of instead of following only our instinct or our hunch on deciding on the features such as color of something, okay, we let the user behavior decide. We let the user behavior decide which color should be there on the website. This is called A/B testing. The term came from pharmaceutical industry, where A/B testing meant on testing the drugs on various patients or animals. Some will be given the drug, some will be given the pacifiers, and and based on that, based on that, based on their response to the pacifier or the drug, we will measure whether the drug is effective or not. In the similar way, A/B testing in e-commerce means whether a particular color of header or particular color of buy now button would drive the sales or not. So out of A and B, out of A and B, which variation here, which variation is more important, A or B? Quickly. Correct. So if we have this data that the variation A got 23% of returns, while variation B got 11% conversion. Okay, let me repeat what does it mean. Here we are showing an example of A/B testing, A/B. Okay, we 50% of the visitors we are showing the red color, and 50% of the visitors we are showing the green color, and we are observing which one is bringing how many conversions. So here the variation A brought 23% conversion as in converting the user into sales. Okay, so 50% visitors, this half has got 23% sales, while this half has got 11% sales. So if there were 50 users, if there were say 100 200 total visitors, 100 went here, 100 went here. Out of 100, 23 bought. Out of 100, 11 bought. Okay, this is an example of A/B testing. So you can see that variation A is more useful than the variation B. Therefore, we'll stick to variation A. All right, Anup and Sanjaya, did I make sense to you? This was done as part of drug testing. A/B testing is also used in drug testing, whereby some patient, let's say there are 100 patients, and out of 100, 50 patients will be given the medication, while rest of the 50 will be given a pacifier, while patients will not know that they are given pacifiers. And the after close monitoring, we will see that whether the patients who got the medicines actually got better or the other one got better. Okay, based on that, we'll figure out which whether medication is working or not. And the same principle applies in deciding on features in high traffic websites like Amazon or other e-commerce. Okay. All right. Question from Andy is, does it mean that the total conversion is 34%? Not. It's actually 17. It's the average of the two. So 34 out of 200 users. All right. Therefore, 34 divided by 2, which is 17. Correct? But good point. All right. So the, the A/B testing is one reason why companies like Amazon keep on keep on increasing the sales by tuning the website. Okay. We have done a lot of A/B testing in case of Amazon. Probably every feature when we are launching, we do A/B testing. Okay, and when it comes to handling that kind of humongous data, if you want to build an A/B testing platform, you will require big data platforms because the data is really huge. Okay, so other big data customers other than e-commerce are government. Government uses big data for fraud detection, and then cybersecurity welfare, as well as justice systems. The in telecom is being used at various levels to understand the customer churn, as in why are our customers leaving? Okay, why are our customers leaving? This can be well answered by data, by understanding how many times the user called, how many times he has been billed, and what has been their signal reception, and so on. Based on the customer's past behavior, you can easily predict whether the customer is about to leave, as well as we can figure out what can a company do, what can a telecom company do in order to not not in order to retain the customer. Okay, the next is network performance optimization. So the based on the traffic, telecom companies can optimize the network performance. Okay, all of these are big data problems. Why? Because most of this data we are talking about millions of users per second. All right. Similarly, calling data analysis as well as analyzing network to predict failures. So almost every problem that telecom has big data to it. For example, you will be amazed to know that one of the person who I consulted with last year, they were having this difficulty in tracking the configuration of each tower. Each tower has equipment, and they need to track the configuration changes to those equipments. And I was amazed to notice that each of the XML files were in hundreds of gigabyte after a while. All right. Therefore, telecom, you will see that any organization which has decent amount of users will end up with a lot of data. Next is the healthcare and life sciences. Anything related to healthcare or life sciences, such as health information exchange, gene sequencing, healthcare improvements, and drug safety. All of those have humongous data to handle. All of these have humongous data to handle. All right. not only humongous data in case of healthcare and some of the problems, the the kind of computing requirement on this huge data is really huge. For example, in gene sequencing, it's not only the data that's huge. Data is of course huge, but it requires complex processing. It requires a lot of work in order to do that, in order to do the gene sequencing. All right. So this was few examples of big data. These were the few examples of big data customers. Of course, as of today, there are many companies who are benefiting from handling humongous data. There are many companies who are benefiting from storing, processing, and handling number of requests per second. Okay, so there are many companies, almost every organization that has some good users, they will they have a requirement of handling big data. Therefore, the big data platforms, whether on their premise or on Amazon, their big data platforms are going to grow. All right. So there are many big data solutions. There are many ways you can solve your big data problems. One of them is using a stack that is combination of Hadoop and Spark. Okay, Hadoop for storing data, while Spark for processing data. Okay, Hadoop makes a good data lake kind of thing. Data lake is a place where we can store all kinds of data from all kinds of sources. And HDFS, Hadoop's file system, provides that very well. Second way of handling your big data is using these new genre of databases called Cassandra and MongoDB and others. These are NoSQL databases or data stores. Okay, Cassandra, MongoDB, and others, they are examples of NoSQL data stores. You can use them in order to solve your big data needs. Okay, the fourth one is using a solution provider like IBM, Google, Amazon, or Microsoft. Okay, you can take a compute engine from any of those instead of setting yours and run your computation there. That's also one way of handling your big data. All right. So before we, um, okay, a question from Anup. Hadoop is also a NoSQL DB. Let me answer your question. A question from Anup. Hadoop is also a NoSQL DB. Um, Hadoop provides one of the components called HBase. Okay, that is a NoSQL DB. We will be covering briefly HBase in this course. Good question. A question from Rahul. We can store files directly in HDFS and run computation. Yes, you can store files in HDFS and run computations using either Spark or any of Spark's libraries or components, or using Hadoop's MapReduce. Okay, we will be talking about these components very soon. A question from Sri Yukta. Does this mean big data leads to data science where insights are drawn from huge data? So big data basically is humongous data. It's not the machinery. The machinery is basically described here. Okay, machinery is described here. Basically, the big data is kind of the problem, and these platforms are the solutions of handling data. Or big data, when you have humongous data, you can come up with creative solutions in order to benefit from this data. All right, very good point. And say, for example, let me give you a correct example with my real life case. Let's take a case of InMobi. There we wanted to increase engagement with our users. Okay, so we had a lot of data lying around, about users, like this user plays this game. Of course, all of this data is does not have name of people. It has only the IDs of people. Okay, so this user plays this game, this user plays that game, and now based on this data, we were able to give the recommendations to the users saying that since you like these games, you may also like these games. Okay, so basically, since we had data, we had platform, we could do data science very easily. Even if we did not use very complex solutions, we simply used Mahat for that, and it was most of the effort was required in engineering, not the science in this case. All right, and that's true in most of the cases in machine learning, data science, or analytics. 95% of the work is collecting and cleaning the data. All right, and that's where the engineering is required. Very good questions. A question from Anil. Could you provide more details about data lake with an example? Okay. All right. So data lake is an idea which means that we should bring down the cost of storing data. Data could be, say, flat files, binary files, text files, or data could be a database. Data could be database file. Data could be XML, data could be JSON, data could be from different people. Data could have authentication on it and authorization on it. So if there is a central system which can help us store such data from different sources, from different kind of users with different confidentiality and privacy labels, then such kind of storage is called data lake. Data lake makes the cost of acquiring and storing data really low. And one of such examples are Hadoop distributed file system. Hadoop distributed file system is a great example of data lake. All right, I hope I've answered your question. A question from Sina: which application is mostly used in the industry, specifically specifically in manufacturing industry? In manufacturing industry, one of the things that are used very profoundly is the operational intelligence. Meaning, when you are in the middle of when you are operating an equipment, you should be able to get the intelligence whether things are going good or not. What should you be doing? That's one example. And for operational intelligence, one needs to observe the output on the output continuously. Okay, so there are many more use cases like such as analytics. Analytics, there are two kinds. One was operational intelligence that I was suggesting, and other is retrospection or introspection or recommendations about the production systems. So there are quite a few applications in manufacturing industry. Okay, almost everything can be improved with predictions. All right, good. All right, great set of questions. Keep the questions coming. That's the reason why we are here. All right, why we are discussing this. All right, great set of questions. Moving on, should we move on or do you have any more questions? A question from Nilesh. I wanted to know if we can store data in any database or a special setup is required for that too. Okay, let me understand. So I want to know if we can store data in any database or any special setup is required for that too. So do you mean that if we can store big data in any database? So if we are trying to say that if we can store data in the database. That's what is data for, a database for. And also maybe you want to know that if we require any processing of data before pushing the data into database. Okay, so what I'm trying to answer is, okay, all right, let me think about it. So if we can store data in any database, yes, or a special setup is required for that too. So if you're trying to store data in database, you generally need to create a table in the database and create columns in this table. And while uploading data into it, you will need to convert your data into tabular format. Okay, for that you would require something called ETL tools. But when it comes to big data, you generally cannot use your existing relational databases in order to store data, and therefore you will require new genre of tools such as NoSQL data stores or um, unstructured places such as HDFS along with analytics engine. Okay, a question from Suresh: how to store Oracle DB data in CouchDB document DB. So most of Couch-based document database or MongoDB, they provide these command line utilities to pull the data from your database into that NoSQL DB. All right. A question from Pawan: what is underlying technology under Google Compute Engine or under Amazon solutions? They have their own NoSQL data stores or a variant of the open source one. Okay, so for example, the uh, Apache Hadoop started from based on Google's paper on storing data that we will discuss quickly. A question from Kiran: in which solution is the data processing faster? Does it make a difference if we build it using HBase, Cassandra, or MongoDB instead of using other engines? So, all right. So there are thin line differences between them. More than the processing speed, there are many other criterias to consider before picking up a data store. Okay. One is one is what is the use case of your data? All right, how fast you're going to access it. All right, so based on your need, you will have to review as well as which one fulfills your what do you say, licensing requirement is another thing. Most of these are having open source licenses, but there are differences between various open source licensing. All right, a question from Suresh. What was the previous question? Okay, so I'm not sure about the CouchDB tool. Most likely they would have provided a command line tool or something with which you can pull the data from Oracle here. A question from Bhuvan: is Spark the distributed computing system and Hadoop the software apps to handle big data? You will get to know very soon. Okay, Bhuvan. If not, then let me know. All right. A question from Anup: is it possible to use Cassandra/MongoDB with Apache Spark? Is it possible to use Cassandra or MongoDB with Apache Spark? Yes, as per Apache Spark's documentation, you should be. A question from Srinath: what is Redis cache and where it is used? It is in-memory data stores. If you want to do processing really fast, you can use Redis cache. Okay, it's an in-memory data store, which means that you will require humongous RAM in order to handle huge data. Okay, so if your requirement is that you want to process few gigabytes of data, or maybe say um, 20 gigabytes of data, then you can use Redis. But beyond that, since it's not fitting into the memory, you will require either another machine or you will require some other system. A question from Heman. Is big databases also uses inbuilt library for statistical modeling or need to load algorithm for that? All right, good question. So most of these big databases, or you can say big data solutions, do provide their modeling libraries. Okay, they do provide their modeling libraries. For example, Spark does provide you the MLlib, which provides a lot of statistical modeling functionalities. Okay, but sometimes if it's not available, these platforms do provide you a mechanism to load your existing logic into these platforms. Okay, a question from Netil. How Cassandra, MongoDB, and HDFS base differ? Very good question. They differ based on their way of storing data. For example, MongoDB stores data in the form of JSON objects. Okay, one is that difference. While Cassandra and HBase, they try to store data in a tabular structure. Okay, columnar tabular structure. We'll go into more details during the course, and and they also differ from each other in their consistency models. HBase is strongly consistent, while MongoDB is is consistent eventually. Okay, Cassandra's consistency can be tuned, and therefore Cassandra is generally a choice when it comes to NoSQL as opposed to HBase or MongoDB. All right, very good question. We would answer this. It's a hard question to answer. We'll answer this during the course. A question from Manoj: How Google File System, how is it different from HDFS? Actually, HDFS is based on Google File Systems papers. So while HDFS was built, the implementation would vary. The way it is implemented at Google could be different, or maybe Google has moved to a newer file system there. All right. So we are not really sure as of today. Okay, a question from Anup. Redis cache can contain structured or unstructured data. So Redis cache can contain any kind of object. So you can safely say that it can contain unstructured data. A question from Prabhakar. Very good set of questions, by the way. I mean, all of you should pay attention to the questions. Uh, question from Prabhakar. With respect to architecture, where exactly Spark progressed? Much faster computation. So Spark essentially tried to use RAM, while Hadoop's MapReduce was using more of disk. All right, so you will understand it maybe in the second session on Spark. We'll go into the detail again. All right, thank you, Sri Yukta. All right, wonderful set of questions. Okay, so all right. A question from Adarsh. Spark is in-memory calculator, right? Not much. You will learn that gradually, as opposed to the common thought. Spark does not really keep everything in the memory. It tries to cleverly use memory in case something is not fitting into the memory. It puts it into the disk and so on. But it does consume more memory than your Hadoop MapReduce program. All right, and that's where the difference lies in the computation time. All right, wonderful set of questions. Keep the questions coming. That's the only way to learn anything. Okay, That's the only way to learn anything. All right. So, what is Hadoop? Hadoop was created by Doug Cutting, who was working in Yahoo at that time. He was in his personal time, he was trying to build a search engine which he called Nudge. Okay, he was trying to build this search engine, and then he was joined by another person called Mike Caffarella in his personal project on building the search engine. And the way you build search engine is by crawling all the website, meaning downloading data from all kinds of websites to your local drive, and then creating index over that data. Now, if you see that problem, it involves storing humongous data. It involves humongous data. As Andy was referring earlier about indexing, this is the kind of indexing which is used here. Okay, so here what you see is basically they were trying to build this search engine, and okay, they were trying to build this search engine, and this search engine involved storing humongous data, and they were kind of stuck. They realized that the existing tools such as databases and file systems are not enough. They kind of declared that it's not possible to use the usual systems. And at the same time, Google published three papers: Google File System, Google MapReduce, and Google Bigtable. And after these three papers, they implemented first a file system, meaning a paper based on the paper called Google File System. They implemented this file system where you could store data in the form of files. Okay. The difference was that this was using many computers. And second was Google MapReduce. What is Google MapReduce? It's a it's a way of processing data using many computers. Okay. Third was Google Bigtable. Okay. Th- that was for storing structured data. Okay. So GFS became HDFS, Hadoop Distributed File System, while GMR became Hadoop MapReduce, and Google Bigtable became HBase, right? So, so they basically implemented these three papers, and combination of all these three is called Hadoop at that point of time. They named it after the toy elephant of Dog Cutting's son, and and that's how Hadoop came into life. Now, it is basically open source, and that to Apache. What does it mean to you? What does it mean to us? It's the reason why we are able to use it in our personal project, professional project, and educational projects, right? So Apache license is probably the most liberal license, and if if somebody is building a tool with the Apache license, it's going to be used by many people. And that's the reason why Hadoop became more popular than any other solution built to handle big data. It's powerful, popular, and well supported. It's a framework to handle big data. Okay, all right. And all of these tools, they are supposed to be distributed, scalable, and reliable. Okay, let me repeat. After a while, Hadoop was no longer only these three components. There were other components that came under that umbrella, okay, under that umbrella. And all of those components that came under Hadoop's umbrella, they must be distributed and scalable and reliable, okay? And basically, they need to be for distributed, scalable, and reliable computing. All right. While computing on using those tools, you should be using multiple computers. It should be possible to add more computers later. And if one of the computers fail, it should not be a problem. That's what reliable means. Okay, so this is what is Hadoop. Hadoop has got most of the tools written in Java. Okay, so this is how the ecosystem looks like. In the second half, we will continue our discussion from here. We will go into, we will give a brief description of the components, and then we will we will we will talk about Spark. We will give the description of every component of Spark and where do they fit in. So stay tuned. We will be back within 10 minutes. All right, I'm posting the time in IST. Somebody can post time in some other time zone. All right. All right, so I'm back. Should we start now? Raise your hand if you want me to start. Whoever is back, please raise your hand. Okay. All right. Great. Wonderful. Wonderful to have all of you back. Great. So before the break, what we learned was what do we mean by big data? Why big data is important? And what made big data happen, right? The device and the connectivity. And then we also talked about what makes big data processing harder by taking a couple of examples. Also, we learned the use cases of big data. All right. In very simple words, the bigger the data, the better would be insights. Okay. The bigger the data, better would be insights. So there is no denying to the fact that if you store and are able to process humongous data, you will be able to come up with better insights. All right. Therefore, we are trying to learn what are the frameworks and the components involved in order to process big data. All right. Great. Great. So we talked about what is Hadoop. Hadoop is an open source solution based on 3 papers from Google in order to process huge data. Okay. The heart of the Hadoop is this file storage, is the basis of entire system. Is the basis of entire system. It's on file storage, everything in Hadoop stands. All right. So what is a file storage? Like you have on your computer, when you click on browser as in file browser, and you go to C colon, that's called file storage. You have files, folders. In the file, you could keep anything, right? That's a file storage. Now, the second component is yarn. Okay, let me go back to the first one again. So in the file storage, you can keep any kind of data. What is so different about this file storage? This file storage uses many computers in order to store data. Okay, so you can have many computers having many hard disks, and then all of these computers together providing you one big folder in which you can create as many as folders possible and as many as files possible inside those folders and so on, right? So this folder storage is something important. It resides on many computers and you don't have to worry about where it's lying. For you, it's just another file system. All right? For you, it's just another file system. Now, second is yarn. Yarn is the resource manager, right? This file storage that we just talked about, it spans over many computers, right? Many machines. And therefore, we can utilize these same machines which are storing data to do the computation. And that's where Yarn comes into play. Yarn manages these resources like the CPU, the the RAM, and the which machines is closer to which data, right? So Yarn is the one which takes care of which which resources are free, which are busy, who has been recently assigned something, and so on, right? Yarn can execute your program in a distributed fashion. Yarn is like an operating system which can execute your program in a distributed way on many computers. Just that when you are creating program for yarn, you will have to do you'll have to build a program specifically for yarn. Okay, so instead of you designing explicitly a program, there is something called MapReduce or no HBase. All right, let me just take HBase first. So what is HBase? HBase is an interesting database. You can call it database, but it's not really a database. We call it a data store. It can store data in the form of records, right? The way we have normal files and folders, and there is a database, right? In the similar way, we have HBase, which is a kind of data store, which can store data in the tabular form, and we have file system, which can store the data in the files way. Okay, all right. So the way normal database stores its data files, you remember if you are from Microsoft SQL or MySQL, the actual files that represent your tables or databases are stored as normal files, right, on the local computer. In the same way, the data of HBase also contains tables, HBase also contains databases inside it like namespaces and workspace and so on. And all of that data is stored on Hadoop distributed file system. All right. A question from Sanjaya. One doubt from this diagram whether HDFS is like HDD of computers. You can think of it like that way because it's made up of many hard disks of many computers. All right. The next one is compute engine called MapReduce. MapReduce gives you this ability to distribute the work on top of Yarn. While Yarn is like an operating system, MapReduce is a compute engine or a engine that runs the program very efficiently i- on a network of many computers. Okay, if you have hundreds of computers, you can run your logic using MapReduce on these hundreds of computers parallelly, and also in case of MapReduce, it will be the code, not the data that will transfer between these computers. So MapReduce makes it possible to run your logic. Your logic could be sort my data by this column, group the data by this column, or give me only these three columns, or maybe very complex. So you can break down that complex application and create maps and reduces to functions and hand over your code to MapReduce. MapReduce will send your code to all the machines to get executed parallelly on many machines. So instead of transferring data, Yarn will execute your MapReduce logic on the machine where the data is. Okay, so MapReduce, after taking, you will talk to MapReduce will talk to Yarn, and Yarn will talk to Hadoop distributed file system to get the work done. All right, we will go into more details of MapReduce during an example, during the course. All right, now since Yarn can execute any kind of logic, Spark came up with its own more efficient way of distributing and executing data. All right. So Spark uses Yarn and HDFS to get your work done. Spark is a direct competitor to MapReduce. Okay. Spark is kind of a competitor to MapReduce. All right. The next is Hive. Now, since It's not really possible to write logic and the code for even the small thing like selecting data from a table or picking up few records from a file. Therefore, there was a need of a SQL interface. All right, there was a need of SQL interface, and that's what became Hive. A question from Sanjaya: what is the difference between MapReduce and Spark? MapReduce was the older mechanism that came with Hadoop, and Spark is a new tool, new product from a different company which runs on top of Yarn. So you don't need both MapReduce and Spark in Hadoop system generally now. In the classic Hadoop ecosystem, there was only MapReduce, okay, and there is no Spark in the classic Hadoop ecosystem. Here we have just put a Spark to give you the perspective. All right. Now, coming back to the Hive, Hive is SQL interface. Hive is an SQL interface so that you don't have to code. You can just write select star from a table and so on. And under the hood, it will it will call MapReduce. So Hive will call MapReduce. Okay, Hive will convert your select query or your query into MapReduce. MapReduce will convert your query. MapReduce will take the MapReduce created by Hive to Yarn, and Yarn will execute it nearer to the data. All right, that's what goes on inside the Hadoop ecosystem. All right. Another tool called Pig Latin, Pig or Pig Latin. Pig is the tool and Latin is the language. Pig Latin was very much like SQL, just that it is little different. It is a little different programming language. Okay. Although Pig Latin is largely out of use, okay, but still we have created a tutorial so that you can get hands-on with Pig Latin. All right. In Hadoop, there was another thing called Mahout. Mahout was a machine learning library, and it was pretty much useful. I have used it personally, and at InMobi. So Mahout is a machine learning library, meaning for doing the computations, the large scale computations or the complex computations, such as computing recommendations, computing linear regression, and so on top of MapReduce. Okay, so that's Mahout. And when you have a big problem, let's say in case of a same example of InMobi, let's take a case of recommendation generation, right? There'll be many more things in it. You'll have to take the raw data from a server, and then you have to clean it up, filter the data. Once data is filtered and ready, then we call Mahout, and then we before calling Mahout, we'll be using MapReduce or Hive in order to clean data or prepare statistics and so on, right? Therefore, in a typical project, you will require more than one components. You will require interacting with many components. Say, for example, in my case, I had to create a directory in Hadoop file system before running my recommendation engine. And then once recommendations were generated, we wanted to use tools like Flume and Scoop. Stats means statistics. So when you have a large scale project, you would require a tool like Uzi. Tool like Uzi. Okay. A Uzi like tool is quite useful to run the workflow having all of these components. Okay. So I missed these two components. One is called when it comes to pulling the data from traditional systems, there are two components. One is called Flume, other is called Scoop. If you have, say, relational database, say Oracle, Microsoft SQL, MySQL, PostgreSQL, that's our structured data. Okay, this is our structured data. And Scoop can pull the data from there to Hadoop distributed file system or Hive. Okay, so basically, Scoop can pull the data from these structured data sources into Hadoop ecosystem, or it can also take data from Hadoop ecosystem, maybe HBase, Hive, or HDFS to MySQL, Oracle, or Microsoft SQL, or Postgres, anything that supports Java database connectivity. All right, because all of these components are written in Java, including Scoop, and therefore, if your database provides a JDBC connection or Java database connectivity, then you can use Scoop to transfer back and forth your structured data. All right. So the other component is Flume. If you want to pump the data continuously from different sources into this data lake, okay, if you have, let's say, many servers operating in parallel and pushing the data continuously, creating these logs, you have these web servers, multiple web servers creating the logs, and you want to push that data continuously into Hadoop distributed file system, then you would require Flume. All right, you would require Flume. So in a typical project, you will be, I'll take again the same example of in Mobi. So what was I doing? I was creating recommendations. And how I was creating recommendations? I was using Mahat. All right. So I was using Mahat to produce the recommendations. And after Mahat, once we had the list of recommendations, like this user would like these applications and so on, right? All of those recommendations, we had to take back those recommendations to our web server. And web server has a database on which we had to push the results. So from Mahat, we had to use Scoop. After Mahat, the results were saved in HDFS, and from HDFS, we had to use Scoop to take the data from here to the structured sources. All right. Now, but before that, we needed Flume in order to push the data from all the web server, the history of users. So first we will take the unstructured data, then we we would use MapReduce in order to clean up that data. Then we used Hive in order to do the basic processing, like pick only the users which are from United States or which are from this particular URL patterns. And then once we were done with that kind of cleaning, we would take the final cleaned data to Mahat. Mahat produced the recommendations, and from Mahat, we took the results to the database. So you see, we used Flume, we used Hadoop file system, we used Hive, we used MapReduce, and we used Mahat and Scoop. So many components were used in a single project, right? So instead of we ourselves doing it, one way could have been that there will be one person who will go and execute all of this, or we would write a script that would run. Okay. Instead of using the Unix shell script or manual way, we used Uzi. What does Uzi do? With Uzi, we can create the entire workflow about in what order things need to be executed. All right. Or you can also use your Java program, Python program, or command line interfaces to interact with all of these components. Okay, all right. So let me take an example. A question from Pavan. Flume is messaging system like Kafka. Messaging system, that's what you mean, right? So yes, so Flume is not really messaging system like Kafka because Kafka has producers and consumers. In case of Flume, it can pick the data from various sources, automatically and can push the data back to a singular place. Okay, so while on Kafka, many people can write to it simultaneously, while Flume itself reads the data sources and pushes the data to the destination. So source and destination is something we define before running the Flume service. All right. While in case of Kafka, we start the Kafka and then various users can interact with Kafka, create the topic to speak about, and various listeners can read from those topics. All right. All right. Reshma, did I make sense with respect to Uzi? Was he able to create? So in case of Uzi, basically we combine all of these things together and can execute things. All right. Great. All right. A question from Sanjaya. Can we save unstructured and structured data in the same database or in same table? Not really. Unstructured data, you would generally prefer to keep it in the file system. All right. Question is, I mean, which best Hadoop ecosystem component for unstructured data? You can store unstructured data using Hadoop distributed file system and process that unstructured data using your code or using maybe Hive can help you also load unstructured data in some cases, not all. Okay. So unstructured data, you will have to take a closer look on how to convert that into table or structured data. A question from Manoj. How unstructured data is handled? How is it stored? Is it necessary to convert unstructured data into structured for processing and storing? All right, let me try to answer again. Okay, so what is unstructured data? Unstructured data is something that is not in a column format, and we don't know the details about the columns data types, right? So a better way of handling unstructured data is you keep that in file, then you can take a look at the data and try to infer what does data look like. Is it JSON? Is it tab separated? Is it column separated? Or is there a regular expression pattern which can match? So using MapReduce or using Hive, using Pig, you can convert unstructured data to structured data. Okay, a very good question from Nitin. Question is, where will Kafka come into this architecture? Where will Kafka come into this architecture? So Kafka basically is an independent component. All right. So these most of the Hadoop is kind of what do you say for batch processing, whether it's Hive, whether it's MapReduce, whether it's Mahot, or whether it's say Scoop. All of these components are batch processing. What does it mean? It means that we take our program, execute it, it finishes and gives back the results. That's called batch processing. The other kind of processing is continuous process. Okay, what does continuous process mean? Continuous process means the program never stops. It waits for input data and produces the output data. Program never stops. Messaging queues are an example, or event handlers are an example. For example, let's say you have built an email system. Let's say it is an e-commerce company which keeps on sending emails to people, right? As soon as you have placed an order, it'll send an email. There are two ways to do it. One, in the code where you have written that transaction finished, now call the email module, right? That's one way of handling it. Second way is we raise an event. We just inform all the people that order has been placed. Now, whosoever is listening to this information about order placement, they will start working, right? They will start working. And that's where Kafka kind of systems come into play. So in an organization, let's say I am having a team, you are having a team, you are responsible for, say, fraud detection, and I am responsible for making running the portal, the website portal, and users come and place order on my portal. So instead of calling a function created by you, like fraud detection, instead of I calling the library of yours, I will just raise an event saying the order has been placed, and you will handle that event. Okay, and how does this communication happen? This communication happen something called event messaging buses, or event buses, or messaging queues. Those are the different name from the same thing. So Kafka is one of the messaging system. So when the order is placed on my portal, I will place an event in the Kafka queue. And since your program is continuously listening on the queue for these kind of events, it will instantaneously, the moment it receives the event packet, it will start doing the work. Okay. So Kafka is one such queue. We will go into more details. And whenever, let's say, you want to do the operational intelligence, okay, like for example, you want to continuously monitor how many orders are being shipped, or how many items are being built continuously in your organization, you will have a Kafka queue in which all the information is going in, and on the other end there is some program which is reading this information from queue and processing it and plotting the continuous chart. Okay, that's how Kafka come into the architecture. Not in this one, but the Kafka will come into architecture in something called the other thing called Lambda architecture. Okay, what does Lambda means? The data is continuously coming from, say, a web server or some other source. Okay, the data is continuously coming from a web server or continuous source. One copy of the data is being stored in Hadoop file system. Other copy of the data is being processed, and the results are being saved in Hive. Okay, so it's kind of inverted Y, also called Lambda architecture. I hope that makes sense to you. A question from Heman. After taking string and string data and do math, the final results are published using visualizer software or any inbuilt visualizer in Hadoop. All right, very good question. So Hadoop does not provide any visualizer. Neither do any other system. Neither do any other systems. Okay, neither do any other systems, meaning none of the big data systems provide a visualizer. All right, and the reason is the reason is the reason is that it's impossible to visualize the big data. One, it's heavily graphics intensive. Second, it does not make much sense to plot billions of points or millions of points on a graph, because eyes are not too sensitive about those number of points. So the general strategy is that you take big data, process it, produce the summary, and then save the data into Hive, and then connect to Hive using your usual visualization systems, such as BERT, such as Crystal Reports, such as Tableau, such as Microsoft Excel. So all of those tools can connect to Hive. All right, all of those tools can connect to Hive, and then give them take the insights produced by big data processing. All right. So Sanjay, I will cover that part quickly. All right. A question from Sampan. Could you explain the Lambda architecture? Definitely. I can just take 2 more minutes. All right. I hope all of you will be benefited by that. Okay. So commonly used term is called Lambda architecture. Okay. Imagine there is an e-commerce website. All right. E-commerce website. Okay. And this e-commerce website, the users are coming to it continuously from all around. It's storing data in the it's creating some data. Okay. So the way it is generally handled is whatever data is being produced by this website, it'll be taken from here and there'll be two copies of it. This one will go to your data lake and this one will go to your real-time processing systems. Okay, this is called Lambda architecture because it looks like Lambda. Okay, is a overly simplified model of Lambda architecture. So e-commerce website is continuously producing data, and we need to do two things. One, we need to continuously monitor what's going on, as well as we want to keep this data somewhere for future use. Okay, this data could be logs. Okay, analytics, as in the click events. This data could be the purchases and so on. Okay, so there are quite a few things that go on here. All right, so yeah, it's a very simplified example of Lambda architecture. Did it make sense to you? In the example you mentioned about converting unstructured data to structured data, we used, in the example that I've talked about, we used MapReduce, Hadoop's MapReduce using Python, and to clean up the data and convert it into some meaningful, as in user ID, user ID, application ID, and how much that user liked to play with that game. Okay, we used MapReduce as well as we used Hive at places to clean up the data. A question from Sanjay, you said Spark is faster than MapReduce, then why Spark is not there in the new classic system? It is there, all right? Whether you take Cloudera or Hortonworks, everywhere you will find that they install Spark with it. Okay, what are the disadvantages of using Hadoop? Very good question. This disadvantage is that since it's distributed and most of the jobs have inherent latency, meaning 3 to 4 seconds of starting up a job is usual. Therefore, if your response time is expected to be in milliseconds, do not use Hadoop. All right. What's the role of Impala stands in ecosystem? I think that we can take offline. All right. Question from Nanda. Is Kafka replacement for ETL? Not really. Kafka is just a queue. ETL is the entire process. ETL is a batch wise, while Kafka is for unbounded data set, as in continuous processing. All right. What is the role of ETL tool here? So most of the ETL is done using these existing tools, but in some cases, let's say your data is really complex and you have already written ETL framework, you have already written ETL tools. In those cases, you can call your program from within Spark or from within MapReduce to clean up parts of data on multiple machines. Okay, all right. Uh, a question from Reshma. What is the competitor of Hadoop? Most of the competitor of Hadoop are these cloud platforms, and there are no SQL databases all around which are trying to solve the same problem. And Hadoop's MapReduce competitor is Spark. All right. A question from Heman. As big data, so we can consider data it is as population or during operation as we take sample from it, or do the statistical modeling to come up with likelihood of event. Okay, let me try to understand Heman. Okay, a question from Heman is as big data, so we can consider data it as population or during operation we take sample. No, okay, I think I got your question. So question from Heman is, while dealing with big data, do we take sample and then do the modeling, or do we consider data as it is? Great question, Heman. So that's exactly the difference between big data and the traditional computing. In traditional way, what we did was we took the sample of huge data. If we realized that the huge data is not really fitting into the memory or we are not able to process it, traditionally we took a sample out of it and then did all kinds of statistical processing. But these tools make it possible to handle the data as it is without taking sample. All right, that's where the big data is playing a humongous role, because when we took sample and did the modeling around that sample, we did not really get many insights. Okay, so that's why these kind of systems are wonderful, because imagine, let's say you have a movie ratings of 1 million users. Okay, and you want to produce the recommendations for these 1 million users, right? If you take sample of this data, the result will be very skewed. The result will not be very useful, right? Therefore, more the data, better the results. And that's why all of these systems are built. Great question, Heyman. Thank you. All right. A question from Ramkumar. Does Mahat support other open sources like Python or R? So Mahat is just a Java library. You can call it from Python. You can call it from anywhere. Okay, just that it will run the thing on top of MapReduce. So Mahat provides you a command line, and with that command line, you can pass the data after storing the data into HDFS. So Mahat's command line can take the path from there. So you can call that command line. You can call Mahat's command either from your R program or Python program. All right. I hope I answered your question. A question from Nitin. Can Flume push data to other than HDFS like Kafka? Custom web upload link. Very good question. Very good question indeed. So question is, can Flume push the data to other than HDFS like Kafka or some custom places? Right, it can. It does provide you a way to define something called sink, S-I-N-K, sink. What does that mean? So Flume can absorb data from different sources by the way of something called source. So you can combine source and sinks to transfer the data from any kind of sources to any kind of sinks. Okay, so therefore the Flume can do that. All right. Just if you think about it, whether it's a network cable, whether it's USB cable, or whether it's USB 3, USB 2, micro USB, mini USB, the wire is same. It's just the source and destination types are changing, right? In the wire, the physical one. correct? Or the headphone, for example, the wire is same, almost the material could be a little bit different, right? Similarly, Flume can be customized to behave like any kind of wire. It can suck the data from any source and save the data in any sink. And there are all kinds of sources and sinks provided with Flume. Kafka is one of those. So it can read the data from Kafka and it can also store the data into Kafka. All right. So very good question. All right. A question from Rachel. So if we need to explain Hadoop in one liner, can we say Hadoop as a ETL tool together with all its subproduct in the architecture? Not really. ETL tool did not do a lot of things what Hadoop does. Just that Hadoop's one of the use cases is ETL because it also provides storage. Storage is not provided by ETL tools, right? So Hadoop is a place where you can store humongous data using many machines and process it. All right. Saying it ETL tool will kind of disrespect it. Okay. A question from Prabhakar. Is it possible to automate Hadoop to give results for unclassified data? Of course. So you can automate as in you can write programs on it, you can call all of this and get the results done. A question from Rex. When it comes to streaming, which is preferred, Flume or Kafka or Spark streaming? Okay, so all right, let me answer this question. When it comes to stream processing, what do we prefer? So we generally prefer Kafka because Flume is kind of I think I'll just describe this way. Okay, if you think about Flume, it looks like this. Okay, many different sources, and they all have a single destination. When you configure Flume, you generally define a sink and the objective of Flume was to take data from everywhere and put in the sink. Okay, so these are all sources, and it was generally designed for sinks like HDFS earlier. Okay, this is what Flume did. Flume did not provide much of a computation, so we can count Flume out of stream processing. It does streaming as in it does the transfer in real time, but it doesn't do the processing. Okay. Well, Kafka is a very interesting solution. Okay. So I'll tell you. So Kafka is, you can see, think of it like a huge queue. There are many topics on it. Okay, there are many topics on it. So people can talk on different topics and listen on many topics. Okay, so these are the speakers on the topics. These are the speakers. Okay, while these are the listeners. Okay, these are the listeners. Okay? They are listening to each topic. Okay, so this is Kafka. Kafka has storage in case, and Kafka runs on multiple machines. As in case one of the machines handling a topic goes down, that is handled by some other machine. Okay, so before Kafka or messaging queue, this was handled by table in which was ordered by timestamp. Okay, it was handled by timestamp. All right, so basically Kafka is a kind of mm, proper messaging queue, while Spark streaming is just processing solution. Spark does not have a storage. It can read, Spark streaming can read data continuously from Kafka. So this is where the Spark streaming would happen. Okay, here will be a Spark streaming program continuously running and reading from Kafka or Flume or other sources. All right. So Flume does not provide processing. Flume only provides transfer, and the Spark Streaming does not provide production of data or transfer. It just listens to it. So Kafka is definitely the end-to-end solution for stream processing. But if you compare the Kafka processing and Spark processing, I would go with Spark processing because Kafka also has started providing its own processing engine. So if you ask me whether to choose Kafka's processing or Spark processing, I will choose Spark processing in case I want to handle the data with a latency of a second. Okay, if my requirement is that I want to process data lesser than a second time, lesser than 1 second time, then I will go with Kafka processing. All right. I hope that answers. A question from Anup. As more and more companies are going to cloud infrastructure, do you think Hadoop has a future? So yes, Hadoop still do have a future because what's happening is at the end of the day, lots of companies are actually storing their data using Hadoop on the cloud infrastructure. All right, they're running Hadoop on the cloud. What processes are there to Hadoop to optimize Hadoop? Okay, so all right, that's a hard question, and I need to think about it. So, what processes are there to optimize Hadoop? As in, when we are trying to process the data on Hadoop, how can we optimize, right? Is that your question? Probably it's a difficult question, and as we go during the course you will learn it gradually because the optimization is not a plug and play. Optimization is the purpose of all of these tools. Why are we using distributed computing as opposed to the normal databases? Objective is optimization. All right, in every case, whether we are talking about Hadoop uh, or Spark during the course, we will learn optimization in detail. All right, very good set of questions. Pawan's question is, where does Zookeeper fit in? Wow, that's kind of I missed. All right, so Zookeeper is a separate engine, and all of these machinery, including Hadoop distributed file system, they all use Zookeeper internally for coordination. Zookeeper is a big whiteboard. Okay, it's for keeping very small memory, and that's where Zookeeper lies. All right, so I would request you to go through the Zookeeper session, and we'll go through Zookeeper's first session soon. A question from Santos: as IoT is booming, will Hadoop take over it? That's a very difficult question to answer. IoT is many things, and it stores it's basically about being able to communicate between various devices, and for that communication we might require a storage of lot of data. So, and that data could go into Hadoop, or it could go into Amazon's, or it could go into Microsoft, Google, or some other cloud service or other NoSQL. So there is no clear way of looking at it. All right. So, but yes, in a way, since IoT generally produces a lot of data, okay, and therefore, these NoSQL systems or big data systems could come into play. All right. Uh, yes. Thank you, Reshma. All right. Great. So this was our Hadoop ecosystem. All right. Great. I'm very happy that all of you are paying attention, and I have a great set of audience today. Great. So we have another ecosystem of Spark. We covered Spark very briefly earlier. All right. So we have something called Apache Spark. Apache Spark is a replacement of Hadoop's MapReduce. It's a fast and general engine for large-scale data processing. Let's look at every word. It's a fast and general engine. General means it's fast as in it's faster than Hadoop. And general engine means it can run any kind of code. It can run any kind of program. That's what general means. For large scale data processing, meaning if you have many computers running, many computers, you can utilize all of those computers for your data processing. That's what it means. Okay. So again, it's not a storage. Spark is not a storage. It's a processing engine. Okay. So it's around 100 times faster if done entirely in the memory. It's 10 times it's 10 times faster than MapReduce. It builds on similar paradigms as MapReduce. Okay. It builds on similar paradigms as MapReduce. Okay. So basically, it's essentially a faster way of doing the computation. It's very well integrated with Hadoop. All right. So Spark Core can run on top of all of these infrastructures. Whether your cloud is running using Hadoop's Yarn, or your cloud is on Amazon's EC2, and your cloud is, if you don't have a cloud infrastructure yet, you can create one using the standalone provided by Spark itself. Spark can run on top of Apache Mesos. The core of Spark can run on any of the provided resource managers or cluster managers. Cluster manager or resource manager is something that help you control and manage and provision the entire cluster. Okay. Also, this Spark can read from many data stores. It can read from HDFS, HBase, Hive, Tachyon, and Cassandra. Okay, it can read from all kinds of sources, and that's what makes Spark really powerful. Now, Spark Core provides you the basic construct of writing logic in Python, Java, Scala, R. Okay, as well as your custom program. You can launch your own Linux program or Unix program or your own Perl script using Spark. And that can run parallelly on many computers simultaneously while reading data from any of these sources. Not only that, Spark Core provides you this great set of libraries. It's called data frames. It's called there is something called data frames. We call it Spark SQL. Then there is something called streaming, MLlib, and GraphX. Okay, so on top of Spark Core, we will have we have these libraries. One is called data frame. Data frames is very powerful libraries, and in this coming course, we are going to increase the dose of data frames because data frames let you process structured data. You can write SQL queries instead of writing code. While Spark Core provides you to handle all kinds of data using using your own programs. So on top of Spark Core, they have written something called a data frames library, which provides you a great tabular structure with which you can process your data using SQL or R kind of logic. On top of Spark, there is something called streaming. With the streaming, you can continuously read data from various sources and process it using Spark Core or data frames. Okay. Then there's something called MLlib. If you ask me personally, I would say that one library which is very powerful for machine learning. That's MLlib. Okay. Why? Because MLlib provides you this powerful way of processing powerful set of algorithms. MLlib is machine learning library. MLlib contains all kinds of algorithms and data structures and pipelines for your machine learning needs. And it does it over multiple computers. So it would be the fastest and most powerful library for machine learning. Then we have GraphX. If you have complex structures, you have complex structures in the form of graph, like Facebook graph or something, you can use GraphX to to provide insight on your knowledge graph or social graph and so on. The things which were really difficult, they have been solved by using GraphX. Okay, and user can access all of this functionality using either Spark R, SQL, Java, Python, or Scala. All right. So this is what Spark architecture looks like. User can interact with all of this using any of these languages and all of these libraries and interacting with the core and so on. All right. So as part of this course, we will learn Scala before jumping into the course because Spark is written in Scala. A question from Heman: is data frames in Spark are same as R programming data frames where data is stored in the form of table? Good question, Heman. So the idea of data frame is exactly same as Spark's, same as R way of data frames. Okay, it's actually inspired by R, but the data structure is inside Spark, so it's not inside R. All right, so it basically the idea is same. A question from Ramkumar: Spark supports only these languages which you have specified on their as per their website. This is what they support, but you can execute any kind of program. Your legacy code can be executed on top of Spark core. All right. We call that pipes, and Spark provides a way to run any program. All right. I mean, the truth is that it's the Scala binding mainly. Python is calling Scala programs, and since Java and Scala both compile to the same bytecode, so Java can use Scala library and Scala can use Java library. Okay, so both are same thing, and R is essentially calling the Scala code, or you can say Java code, and SQL is also SQL is basically connecting to Spark server. A question from Santosh: I don't think any programming language can work for Spark except they mention. So you can create wrappers for these libraries. Okay, you can create your own wrappers, and as of today, the idea that a single programming language idea that you need to do things only in one programming language, that's not there anymore. Okay, so generally you can create wrappers around most of these libraries and call them from anywhere. Like for example, Java APIs can be called from C, C++, and vice versa. All right. Thank you, Reshma. All right. So, but most efficient way of using Spark would be via Scala. Why? Why do we need? Why are we not learning using Python? Although Python is a very preferred choice of most of the data scientists, why are we not doing that? Because sometimes what happens is before releasing their API in Python, there are some functions which are not available. For example, GraphX was not available in Python earlier. Okay, therefore we end up with switching back and forth between Scala and Python. So to keep it uniform, we chose Scala, and Scala is a faster version of Java actually, and it's easier than Java. It's more like somewhere between Java and Python with respect to easiness, and it's as efficient as Java. So that's why we have chosen Scala as the language. All right. Spark R is on R. We have to call Spark libraries. Is that yes? Spark R is a R console in which you are provided couple of more objects which talk to Spark. Okay, we will learn that. A question from Rakes. When it comes to performance, which is preferred for Spark, Python or Scala? Performance-wise, Scala is preferred, but since it's a distributed computing, it does not matter much. Okay. Second idea is that since it's a lazy execution, meaning only when you say execute, it will execute. Okay. It would not bring the data back and forth between Scala and Python, and therefore, whether you code in Python or Scala, the difference will be less visible. Okay, unless you are doing actual execution using Python objects. All right, so there will be slight difference. There will be slight difference using Python Scala. But having said that, mostly if you compare the performance, you can see that there is a visible difference between Scala and Python. So a question from Sri Yukta. Question is what exactly it is mean by Spark Core? Basically, this is where Spark got started. Okay, this is something that is core of it, and these are additional libraries like Java had Java core engine. Then there are these additional libraries around Java, right? Similarly, we have Spark Core, which does the entire mechanics of distribution of work on many computers. And then there are these libraries which internally call Spark Core. All right. All right. So yeah. So that's about the Spark architecture. All right. Okay. So there are a couple of seats left in this course that's running now on Spark. If you are interested, you can join. Okay. And the next session will be on coming Saturday. Okay. So, all right. So you can not here. If you go to home folder for home page and click on view details, all right, and you can enroll here. All right. A question from Nanda: how does Spark okay? How does Spark achieve 10x performance over MapReduce? Very good question, Nanda. Basically, Spark utilizes memory during processing. Whatever available memory is there on each machine, it tries to utilize that memory. When I say available out of the allocated memory, right? We allocate certain memory for on every computer inside Yarn. We specify that the container should not take this much memory, right? Out of that memory, Spark tries to utilize as much memory as is left in order to make the overall performance faster. All right, good question. A question from Sri Yukta. How is partitioning of data done by Spark? Basically, it's done using something called Resilient Distributed Dataset or RDD that we will study soon. All right. Okay, any other questions? So those who have not yet enrolled, you can enroll. It's so okay, I think I'll do one thing. All right. So we have, if you log in into CloudX Lab, those who have already taken the subscription, they will be able to see my courses. If you take your cursor to your login, you'll be able to see my courses. There you will have the listing of you will get a few things. One, you will get the Big Data with Hadoop and Spark course. It's a pre-recorded course and it has all the exercises and all the assessments. So during the course, we will go exactly in this order. So you have to finish all the assessments and the videos as we go, except for Java Essentials. We will be basically Okay, we will be going in the same order. All right, so try finishing this as we go through our live course. We will be also providing you the live recordings here and also complementary courses. Okay, complementaries such as regular expression, Linux, Java, and also we'll be providing the Scala courses as part of this course. This is probably the most exhaustive course on big data with Hadoop and Spark. All right. Also, along with that, you will see the lab details. Lab details is what? We have set up the entire cluster for you so that you don't have to worry about setting up your own environment, as well as the access to this lab can you can access the lab via the browser. Whether you are working from home or office, you can access it from anywhere. Okay, and your data is saved in the lab, so you don't have to worry about losing the data. All right, so you can click on say web console here. All right, you can click on web console. I'm just going to show you what does it mean. I'm logging in into here. This is my login and password. What is web console? It's access to the whole cluster by the way of Unix shell. It's a Linux shell here. Okay, and for me it is e.cloudxlab. For you it could be F or G or H. Okay, so here this is what is the web console. From here we can talk to Hadoop using Hadoop FSLS. So entire infrastructure is set up for you. Okay, we are the pioneers of setting up lab in this industry, and most of the players are using our infrastructure. Now, let's take a look at Ambari. Ambari is the tool that is provided by Hortonworks in order to provision and monitor your infrastructure. Okay, I'm logged in as admin, so I can see the status. All right, so you can see that there is HDFS, whatever we learned. There is HDFS, which is running the various services. We'll go into the details. There's MapReduce, there is Yarn. We have turned off some of the uh, processes. We have HBase, we have Hive, we have Oozie, we have Flume, we have Kafka, we have Mahout, we have Spark, and so on. All right. So we'll also learn about Zookeeper as part of this course. And we have a Scoop also here. So the entire ecosystem you can see via Ambari. While if you want to interact with individual component, a right way would be Hue. Okay, if you want to take a look at HDFS, you can go to the file browser. All right, so this is the file browser. It has folders and files and so on. And inside here, you can see the data folder. It's a common data that we have kept for all the users that you can use for processing. Like movie lens example we were talking. This is the folder that contains the movie lens data. All right. Now here you can interact with Hive, you can interact with Pig, you can interact with Oozie using Job Designer. You can also interact with HBase and Zookeeper from here. All right. Although I will prefer Zookeeper's command line. All right. So we have the entire infrastructure for the distributed computing. All right. If you want to, let's say, get started with Spark right away, you can call Spark, and we have multiple versions of Spark. You can see Spark 1.6, 2.0.1, 2.0.2, and so on. Okay, so if you, let's say, want to launch the latest version, you can simply say Spark shell. Okay, all right. So you can right away start with experimenting with all kinds of tools. We are not restricting you to one particular tool or one particular technology. If you want to work with Python, work with Python. If you want to work with R, work with R. All right. On top of it, we also provide Jupyter and other technologies. All right. So this is your Spark with Scala. Okay, so you can talk to Spark via the Scala console. All right, this was a quick example of Spark Shell. Now, let's say you want to learn just Python. You can just launch Python here. And if you want to use TensorFlow, you can just use TensorFlow here. Okay, all right. So this is how you can actually interact with all kinds of technologies. TensorFlow is a deep machine learning or deep learning tool from Google, which is latest, and people are using it for various kinds of needs. All right. So we have made everything available on the cluster, so you don't have to set up or worry about the resources or access. All right. So this was a quick overview of our lab. And if you there are a few seats remaining, you can take you can enroll if you wish to. All right. I'll just post this URL to you. Okay, a question from Santosh. How RDD and data frame is different? RDD is an array of unstructured data, while data frame is having columns and their definition, and therefore that's structured. Okay. Heman's question is, can you show an example using Hadoop or Spark if possible? I can actually share you with the video of all of this. We have already shared on our blog. You can take a look. I actually conducted only a Hadoop Spark getting started session, so I can share. Maybe somebody from my team can share with you. All right. Difference between Hortonworks, Cloudera, and MapR Hadoop distributions. So they all use the classic Hadoop plus they provide few extra components. For example, Ambari is Ambari is provided by Hortonworks, while Hue is provided by Cloudera. So what we have done is we have taken the best of components from all of these and set up here. All right. The other question is, what data sets come in Spark? So there is not much data set that Spark provides. They just come with their own example data sets. Okay, those example data sets are very small. Okay, we have set up the data sets for you. For example, this is a Twitter sentiment files here. Okay, you can take a look at this. This is New York Stock Exchange data, and there are log messages and there is you know the sentiment analysis if you want to do here. There is there are quite a few kind of data sets. There is let me go up one more. There is a folder called datasets. It contains the dataset from Coursera, Enron emails, and many other sources. So you may like to take a look at it. All right. Question from Dilip. What are the variables available in Spark? Maybe you mean to say that what are the variables available in Spark Shell? There are two variables generally. One is called SQL context, other is called Spark context. Those are the two variables, but that is been changing. So in Spark 2, there is one variable called Spark that is available to 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 all, and that's what will be used in most of the situations. Okay. All right. Great. Very great set of questions, and keep these questions coming. That's the only way to learn. And these classes that we run are for answering your questions. All right, Nitin, go ahead. You have a question. You raised a hand. All right, wonderful to have all of you in the session. Please feel free to ask questions. Also, come over to our discussion forum. Our discussion forum is quite active, so you can keep on asking questions. Me, Abhinav, and some more people from my team would love to answer your questions. Okay, so come over to our discussion forum, or as well as if you want to come over to the the course, you just can enroll there. Okay, all right. So there are a couple of seats left. So if you want, generally my seats get filled up pretty fast. So you might as well hurry up. Okay. So All right. So feel free to reach out to us at reach us at CloudX Lab. And it's wonderful to have all of you in the session. Okay. Thank you, everyone. It was a great experience answering all of your questions. All right. These are a wonderful set of questions. I thoroughly enjoyed them, and I definitely got better perspective on things. All right. Thank you, everyone. Have a great day ahead. I look forward to see you in my session. All right. Thank you. Thank you. Thank you, everyone. Bye bye.